Hello everyone, welcome to Aruba Central AOS-CX switching demos. In this demo, we'll see about dynamic segmentation. So let's start with the overview of user-based tunneling. AOS-CX switches supports user-based tunneling, part of the Aruba Dynamic Segmentation solution that implements the capability to tunnel traffic on a user or device basis based on GRE and sending the traffic to the Aruba gateway. So let's see how user-based tunnel, alias UBT, works. UBT uses the concept of colorless access ports. So there arises a question, what is a color or a colorless ports? The colored port in a legacy network signifies when the ports were assigned a color physically on the switch so that specific policies assigned to the port. The specific devices were assigned a color and could only be plugged into the corresponding ports. Whereas the great benefit of using the colorless ports is that we no longer have to statically pre-configure the access ports to a specific policy and port attributes. By using these colorless ports, the IT operation cycles are significantly reduced, leading to efficient planning for initial deployment or ongoing configuration changes, which will accommodate any future additions, moves, or changes. Let's see how it works. Many devices require network access such as security cameras, printers, or payment card readers or medical devices do not have any inbuilt security software like in desktop or laptop computers. So these devices can pose a risk to our networks with the lack of security on these devices. So the first foremost thing is security has to be enabled on the access ports. So once these end clients has been successfully authenticated, we can enforce policies and rules. These rules will create a tunnel to the gateway. And once this tunnel has been formed, all the traffic from this user or device will be sent to the gateway for further processing, like it can have additional security capabilities and deep packet inspection. As we have seen the overview of user-based tunnel feature, now let's take a deep look into the advantages of this feature. The UBT provides a secure and flexible control of our access layer. With ClearPass or from our switch configuration, we can make sure only a specified device or user can access to the mobility controller. So once the user has been authenticated, the policies can be applied. The policies can contain the QoS, AC, or rate limiting that can be either enforced at tunnel points or at the gateway. And we will have access to the controller applications such as stateful firewall and app RF that will do a deep packet inspection. The policy enforcement can be achieved either through a local user rule or downloadable user rules. The local user rules are entirely configured in the switch and it will be applied from the radius server, whereas downloadable user rules are entirely configured on the ClearPass and it will be pushed to the switch. User-based tunneling also helps us with high availability and scalability. It can load balance to multiple gateways for high scalability and it can handle stateful failover to standby gateway. With these advantages of user-based tunneling, in the coming demo, we can see how the entire feature can be configured from our Aruba Central. So as part of this demo, we'll be covering the configurations of following entities that are required for forming a user-based tunneling: ClearPass, Aruba Gateway, and AOS-CX switch. The prerequisite for this demo is Aruba Gateway and AOS-CX, which should be already onboarded in our Central UI group. So let's see the topology required for this dynamic segmentation feature. So we need the access switch and the aggregation switch and Aruba gateway, and then the ClearPass policy manager acting as a radius server. So our access switch and aggregation switch and Aruba gateway are being connected over internet and centrally managed by Aruba Central. So all the configurations of these three devices will be done only through the Aruba Central. And we do have a wide client that is acting as a UBT client post authentication. So here the access switch has been connected to the aggregation switch over lag interface, and from the aggregation switch we have our ClearPass policy manager and then our Aruba gateway. So there will be a UBT channel formed between our access switch and then our Aruba gateway. So in this demo we'll show about UBT 2.0, which is a reserved VLAN mode where we'll be using a reserved VLAN for the UBT communication. So let's start with the ClearPass policy manager configuration. So if you go to the configuration enforcement profiles, here we can apply either a local user role or downloadable user role for the end clients. First, let's see a local user role. So locally, the user role definition will exist in the switch. Only the attribute will be applied in the ClearPass policy manager. So here we're calling it as radius Aruba, and then the radius attribute is Aruba user role, and then the name of the role is UBT underscore role. This is a sample name for the role. So the definition for the role exists in the switch. So next comes the downloadable user role, where the definition of the role exists in the ClearPass. So here we have created a downloadable user role profile specific to a AOS-CX box, and then we have the definition for the downloadable user role. So where we'll define the role name, and then the gateway zone, and then the gateway rule that will be applied to the end client post successful authentication. So we can either use a local user role or downloadable user role for the UBT. Now let's see the central configurations. Here we have created a dynamic segmentation UI group. So this is a UI group where the configurations can be done via UI options. So first we have to onboard both our switches and gateway in the UI group. So if you see here in the switches, we have our access switch and aggregation switch has been already onboarded, and we have onboarded a gateway as well. So first let's see the configuration of a gateway. We'll navigate to the gateway page and then move to the device page. So here we can see all the configuration options available for the gateway. So we'll start with the network configuration first. We'll go to the interface tab and we'll create the VLANs. So we will require 3 VLANs for the user-based tunneling. The first VLAN is the client VLAN. It is we applied for the end clients. And then the UBT reserve VLAN for the UBT 2.0 mode. And then a wired VLAN that will be used for the communication between the gateway and then our access switch. To create a VLAN, we have to click this plus icon. And we have to provide a VLAN and name and then an ID. So once the VLAN has been created, we can edit the VLAN by clicking this pencil icon. If we scroll down, we can have option to provide the IPv4 address. So here we have given a static IPv4 address. So once the VLAN has been created, next comes the interface configuration. So we have to navigate to the ports menu, and then we have to identify the port that will be connecting between our gateway and then our access switch. So here this is 001 port that will be connected between our gateway and then the aggregation switch. So we have to click the port, and once we can have to scroll down, and the type of the port is a LAN port, and admin state has to be up, and the port has to be trusted, and the port mode is trunk because it has to allow all the VLANs, and we have to mention the VLANs that has to be allowed for communication between the gateway and then our access switch. So here I have allowed all the 4 VLANs. So once the interface configuration has been completed, we have to move the system IP address. So that is the primary IP address that will be used for the communication between the gateway and then our access switches for user-based tunneling. We have to go to System General tab and the system IP address. And then here we need to select the VLAN 2. That is the VLAN that will be used for the communication between the gateway and then the access switches. So once the interface configuration has been completed, we have to go to the security menu. So here we have to create rules and then policies for the end clients once they have been successfully authenticated. This is a sample rule that has been created. So once the rule has been created, we can edit the rule. So we need to provide policies for the end clients. So these 2 policies will be available by default. And after that, either we can add our own policy or we can add the existing policies by clicking this plus icon. So here there is an option to add an existing policy or create a new policy. So if we are adding existing policy, we can create it and then we can identify any of this policy and apply it. So here the existing policy allow all has been applied, and it will allow all traffic from the end clients. And next comes the network part. So here we can specify the rate limiting options for the rule. And then the mode part where we can provide the VLAN. So here the client VLAN has been assigned in that rule. So this is the VLAN the client will be placed after successful authentication. So these are the minimum configuration that is required in gateway for a user-based tunneling. Just configurations now. So we have already onboarded two devices, both the access and aggregation switch. So here we can go to the config menu. So here we have options for creating configurations in our CX switches. So if we configure any of these parameters in this tabs, so it will be creating the configuration in both the switches. So it is a group level configuration available. So we can create a VLAN that will be applicable to both the switches. So we can have a VLAN as 2, and then the name for the VLAN as uplink VLAN, and description as uplink. And have the admin status up, and then save it. So as mentioned, these changes will be applicable to all the CX switches in this group. So once this VLAN has been created, we can move to the device specific configurations. So we'll go to the devices page. And we'll move to the particular device. Like first we'll start with the aggregation device and move to the device configuration page. So here we'll be creating the IP address for the VLAN and then a lag interface for connection between the aggregation switch and then our access switch, and then an interface between our aggregation switch and then the gateway. So first we'll start with the VLAN. So there is already the VLAN creator. So for the created VLAN, we can edit it and provide it a IP address. So I have given a static IP address here. So after the VLAN creation, we'll go to the interface configuration. These are the minimum configurations that are required in aggregation switch. So next we'll move to the access switch. So we'll go to the access switch page and navigate to the device page. So similarly here as well, we need to create a IP address for the VLAN. So there are two VLANs created. The VLAN 2 is for the uplink purpose, connectivity to gateway, and the VLAN 4 is the reserved VLAN for UBD 2.0 mode. In this VLAN, we have created a static IP address and assigned to it. So you can do it by clicking the VLAN and then editing the VLAN by clicking the pencil icon here. So once the VLAN has been created, we'll go to the configuration page again. Next comes the interface configuration. We need to create a lag and then assign the VLAN to it. So there is a lag has been created. And then we have given the VLAN mode as trunk, and then we have assigned as native VLAN 1 and allowed VLAN as all the VLANs. So for creating the lag, we need to press this plus icon and give the name for the lag and then the description for it and which are the port numbers we wanted to add as part of the lag, and then the mode, and then the lag mode and admin status up. So this lag one will have the ports connecting between the aggregation switch and then this access switch. So once we have created the connectivity, next comes the security configurations. First comes the authentication server. So we need to create a radius server for having the user-based tunneling configuration pushed. So we'll go to the radius, edit it, where we can add a particular IP address for the radius server. So here we have to provide the IP address for the radius server, the default authentication port, and then the shared secret key, and then the VRF where the radius server will exist. So once the radius server configuration has been made, we have to do the configuration for the dynamic segmentation. So here in the dynamic segmentation, we need to mention the cluster. The default is the default cluster. And then we have to provide the controller IP address, whether it is UBT reserved VLAN mode or extended VLAN mode. If it is reserved VLAN mode, we need to provide the reserved VLAN ID and then the source interface for the UBT tunnel. If the source interface doesn't exist, we need to create an interface and then assign it to the interface. And next comes the client rules. So here we'll be creating a user role that will be applying to the end clients once been successfully authenticated. So this is the LUR we have created. So we can click the press icon for creating the role and then provide the VLAN mode. What is the VLAN that has to be assigned? And whether if it is user-based tunnel enable, it has to be given the cluster and then the secondary rule that will be applied from the gateway. So once the rule has been created, we need to configure .NX and MAC authentication on the end-client connected port. So here we'll go to the authentication tab. And we need to mention whether the .NX authentication is EAP mode and MAC authentication, it has to be over a PAP or a CHAP. And we need to identify the port that will be enabled with both .NX and MAC authentication. So we need to navigate to the particular port and then click the edit icon. We can identify this authentication method as concurrent and then the priority is .1x and we can specify the client limit. If required, we can provide a reauth period or cath reauth period. So these are the minimum configurations that are required for user-based tunneling in our CX switches. Now the client would have been onboarded. We'll see the client details. So we can navigate to the client page. Here, third port is where the end client has been connected. So we can identify the client has been connected to third port. And then the client has been assigned an IP address and the usage of the client is provided. For details about the client, we can check the client specific page. So here it will display the client details. So what type of client it is, what is the MAC address of the client, and then what is the gateway rule has been assigned, and if it is a tunnel client, and then the VLAN. So it clearly mentions it is a tunnel client, and this is the gateway rule, and this is the VLAN assigned from the gateway. And it will display the data path for the client. So this client details we can see in this page and even in the gateway. So we can move to the gateway. And visit the gateway page. And visit the client page in the gateways. So here it will display the client, like the client name. So what is the rule assigned for the client and which is the port it has been connected and which is the VLAN. So we can click the client. So it will display the client details, the client name, the MAC address, and then the VLAN assigned and the gateway rule. And again, it will display the entire data path of the client. It's been connected from the port 113 to the access switch, and from there is a user-based tunnel being created to the gateway, and then the tunnel is up. So this is how we can able to see the user-based tunnel between the end client and then the gateway. So if we wanted to test the connectivity between this end client and the gateway, we can use the tools option. So we can do a network check. We can ping the client device from the gateway. We can select the device type as gateway and source as the gateway. And then the type as ping test and destination as the host name or IP address, and mention the IP address of the client. And we can start a ping test. So from the gateway, the client IP address will be pinged. So here we can see the success rate is 100%. So the gateway is able to ping the client device. So now we have seen like how a user-based tunnel has been configured from both our gateways and then CX switches, and how the end-to-end connectivity has been tested from our Aruba Central. So with this demo, we will be able to do configurations in our CX switches and then our gateway without touching the console of these devices, and we'll be able to showcase our user-based tunneling.